still looking at ductile material, and this is the second theory that can be used for ductile material, which is distortion energy theory. This theory gives more accurate results than maximum shear stress. So in this theory, we say that distortion, total distortion due to stress, happens because of two things: hydrostatic component and distortional component. The hydrostatic component, we say sigma is equal in all three directions, and then distortional component is responsible for the change or distortion in the shape. Okay, so if you follow the math here, you need to use the strain energy per unit volume for each direction, and the bottom formula here is the strain energy, and then we reduce the formula into distortion energy is a total energy minus average energy, volumetric energy. Okay, this can be reduced further into this formula here. That's the distortion energy theory. This predicts failure when distortion energy exceeds distortion for tension test specimen. Okay, so this part of the formula is compared with yield strength. So in this part, in the left hand side part, we see sigma 1, sigma 2, and sigma 3. So this part at the left hand side is called von Mises stresses. So what is von Mises stresses? Von Mises stresses is a stress that combines all other stresses, sigma 1, sigma 2, sigma 3, or even, so we have two types, two formulas that can be used. If you have sigma x and sigma y and shear, you can calculate von Mises stress. Or if you have the two non-zero stresses, if you have the two principal stresses from your formula, you can also calculate von Mises stress. So von Mises combines all stresses in one expression we call von Mises stress, and then we can compare that stress to strength of the material. Okay, if that stress is larger than strength of the material, then we can say there's a risk of failure. Of course, we always need to incorporate or introduce design factor to make sure that our stress is much lower than yield strength. Okay, so von Mises is compared to yield strength, and von Mises must always be less than yield strength. Okay, so now this is the curve here represents von Mises stress, and we added that safe zone to our previous maximum shear stress theory. So it's more accurate results. If you need accurate results with low factor of safety, then use distortion energy theory. You can use maximum shear stress theory for situations where reliability is not desired, and for rough estimate, and when results you don't need agreement with your experimental results. Okay, now what if we have shear only situations, pure shear loading? We don't have stress, we only have torsion and shear. In this case, we can still calculate principal stresses and do the normal calculation, or what we can do, we can start with this. Yield strength for shear is half yield strength, and then check your shear stress against your yield strength. You can either use half yield strength if you're using maximum shear stress, or instead of 0.5 yield strength, use 0.577 yield strength for distortion energy theory. So it's up to you. If you need more accurate results, use distortion energy theory.